So this set of notes is going to finish off objectives 3 and 4, that worksheet. That's just one worksheet. So we're going to focus on finding points of intersection between two graphs. And we're going to start with kind of a review real quick of the equation of a circle in polar form. And then I want to show you a special rows as well. So first up, a circle in polar form. Remember that you'll just have an equation, something like this. R is 2. This is telling us the radius is 2, that the circle is centered at the origin. And so we just have a center at the origin, and we'll use 2 units in every direction. So remember, if you're wanting to convert that to find the equation of the circle, all you'd have to do is square both sides. This would lead us to replace r squared with x squared plus y squared, and 2 squared is equal to 4, and that is how we write the equation of a circle. So you can see here the center 0, 0, and the radius 2, and that's what we have here in the picture. So like I said, I also wanted you to see something called the special rows. It's really just a circle, right? So it's a rose with one leaf. All right, so you remember the equation of a rose, A cosine n theta, or A sine n theta. So what we'll have here is either R equals A cosine, instead of n theta, where n could be, anything really, n is just going to be 1 here. Okay, remember n determines the number of leaves. So R equals A sine theta. So you'll notice that n is 1. And when n is odd, this tells us that n is the number of leaves. So 1 leaf. All right. So to sketch these, we'll just keep in mind that A, like before, is going to tell us the distance from the pole to the end of the leaf, 1 leaf, and then cosine and sine is just there to tell us which axis that it lies on. So remember that positive cosine is going to be the positive x-axis, negative cosine, the negative x-axis. Positive sine is going to be the positive y-axis. Negative sine is going to be the negative y-axis. All right, so let's do an example here of a special rows. All right, so on our grid, we're going to have a point at the pole. And then the fact that we have negative sign tells us that we want to have our circle on the negative y-axis. So what we're going to do is from the pole, 4 units down, 1, 2, 3, 4, right here, and we plot a point. So this is actually the diameter that we're looking at. That's the diameter of our circle, which means that the center of our circle is right in the middle at 0, -2, and we can see that there's a radius of 2. So we also want to go 2 units to the right and 2 units to the left, and that would create our circle there, or our rows with 1 leaf. All right, so what we're going to do now is we want to find points of intersection between different types of graphs. So we're going to see the special rows a lot. We're going to see just a basic circle a lot, and we'll see some other graphs in here as well. All right, so we're going to start with an example where r is equal to 1 and r is equal to 2 cosine theta. So we are going to draw these two graphs together on the same axes, and then we're looking for where they intersect. So r equals 1. We have our circle with a center at 0, 0, and a radius of 1. Okay, and then over here we'll do 2 cosine theta. So this tells me, remember it's a rows, so we have a point on the pole. Positive cosine telling me that I want to go in the direction of the positive x-axis, and I want to go 2 units in that direction. So 1, 2, and remember that that is the diameter there, that distance. So that marks the center at 1, 0. So I have to finish my circle here. The center is at 1, 0, and so my radius here is 1. From the center to each end of the circle. So up 1 unit and down 1 unit, and then we will have our circle here. All right, so our job now is to find where these two intersect. So this point up here and this point down here. So one thing that we know already is that the radius has to be 1, and that's because we were told that at the beginning r is equal to 1. So when I write out my coordinate pairs, 1 comma something and 1 comma something. So now I'm looking for this angle. What angle would I have to make to get to these 2 points here? All right, so because I have back at the beginning what r equals for both equations, we're going to go ahead and just set the two equal to one another. So I have r equals 1 and r equals 2 cosine theta. So setting them equal, 1 equals 2 cosine theta. That'll tell us that cosine is equal to 1/2. And so this happens when theta is pi over 3 and 5 pi over 3. And sure enough, if we look at our graph and start when r is 1, we would make an angle of about pi over 3 to get up here at the top. And to get into quadrant 4, we'd have to go 5 pi over 3. So those are going to be our angles. Okay, and so we have our coordinate pair. Okay, so let's do another one. So in this one, 2 cosine theta and 2 sine theta. So this one doesn't come right out and tell us what r equals, because it's not just r equals 1 or just r equals 2. So instead, we'll have to do something else to figure out what the radius is. So let's go ahead and start with our graphs. So 2 cosine theta is the same graph that we just did in the previous problem. So it's a rows. We have a point at the pole. It lies on the positive x-axis. We want to mark 2 units out for the diameter, and it gives us a radius of 1 from the center, which is in the middle of the diameter at 1, 0, right? So there's that one. And then for our 2 sine theta graph, so this is just like the last one, except it lies on the positive y-axis. So a point at the pole, 2 units up. That would be another point on the other end of the circle. That marks the diameter here at 0, 1. A radius of 1 takes us 1 unit to the right and 1 unit to the left. All right, so we can see where these points meet. So we are looking for the coordinate pairs here and here. So really easy. There's a point at the pole where they meet, 0, 0. And then there's another point that seems pretty easy to figure out. If you say the radius is 1, though, you would be wrong. The reason why is that point is located at 1, 1. That's in rectangular coordinates. 1 unit to the right, and then 1 unit up. 1, 1. So if I were to draw, remember the radius is the distance from the pole to that point. This is R. And so you'll see it makes that nice right triangle with the legs 1 and 1. And that tells me that my radius is √2. So we're going to start with a radius of √2. And then we have to figure out what this angle is. And you probably can already tell. If that's 1, 1 √2, that's a 45, 45, 90 right triangle, which would give me an angle of pi/4. Now you can also do like we did in the previous problem and set the two equal to each other. In which case you'll get cosine equals sine, which happens at pi/4, as well as 5 pi/4 and other values. So it just depends. I could use the answer of 5 pi/4 if I started with a radius of -√2. So notice that would put us over here on the negative x-axis, and then I would need an angle of 5 pi/4 to get all the way around. So alternate answer here. All right. Okay, so for this last one, we're going to start with -2 sine theta. So this tells me the negative y-axis this time. So same circle as last time. We're going to start with a point at the pole. We'll go down here 2 units, which marks our center right in the middle at 0, -1, and gives us a radius of 1. So 1 unit to the right and 1 unit to the left from the center, and that'll give us our circle here. All right, and then we have theta equals 2 pi/3. So this is just a line. And all I'm going to do is make the angle 2 pi/3 with the x-axis. So 2 pi/3, 120 degrees is going to take us over here. So remember that you make that angle with the positive x-axis, and then you also make that angle with the negative x-axis. And so what happens is it just continues on through the other side. So it's just a nice line. All right, so finding the points of intersection between the two graphs. The first one is pretty easy to spot. They meet at the pole, so 0, 0 is one of their points. The other one is down here on the circle. All right, so we have to figure out the radius and the angle here. Now the angle might be kind of obvious. They told us the angle. It's 2 pi/3. Remember that depends on which radius you start with. So let's figure out the radius here. And all I'm going to do, instead of setting the two equal, because they don't have both r equals, we're going to take 2 pi/3, which is theta, and just substitute back into the other equation. So that'll give me r is equal to -2 sine 2 pi/3. So we'll just evaluate. Sine of 2 pi/3 will give us √3/2, and this leaves us with -√3. So if we start with a radius of -√3, so that would be over here, what's the angle we would need to make it here? So that distance is going to be our 2 pi/3 that we are looking for, since that's what we used to get that radius. So those would be my 2 points of intersection. . Now, if you want, you could start with a radius of positive root 3, in which case, if you did, and then you also wanted to give a positive angle answer, so the angle that takes you all the way around to here, root 3, 5 pi over 3. So that is an alternate answer that you could give. All right, so you can see for several examples, we just set them equal. We found the radius either in the first problem because they told us what r was. If you simply have an r equals a number equation, that's your radius that you're going to use. In problem like number 2, we didn't have what r equaled. We have it in terms of a sine or a cosine graph. So it's not going to be 2 or whatever that coefficient is. Instead, you kind of have to solve for it by, I used the picture actually, right? We used the picture to make this right triangle 1, 1, root 2. Otherwise, you could actually take your angles from solving and plug them back in. So we came up with theta is pi over 4 and 5 pi over 4. If you plug those back into either equation, you can end up solving for r, and you'll get root 2 or negative root 2. And then in problem number 3, we found it by substituting theta into the equation for r.